the motor which generates the encrypted message as the Enigma engine. This code book will be set for each day. It will be changed each day. So this is a transposition cipher where you don't have the key itself. You can make it row wise and column wise in the matrix form. Hello students, welcome to the next session of Network Security. I am Dr. Soumeshri from Department of Computer Science, Vidhyaashram College. In the last session, I explained you about the rotor cipher and the hill cipher, isn't it? So rotor cipher uses a method of rotating the characters, rotating a motor to generate a character for each of the plain text for generating a cipher text. Okay. Now, today in this session, we shall look at what is the actual use of rotor cipher. It was actually implemented during World War II. Now, I'll explain you how they have used this rotor cipher to generate an encryption message during the war time. Okay, they named the motor which generates the encrypted message as the Enigma engine or Enigma machine based on the rotor cipher method. Alright, Enigma machine was invented by a scientist known as Scherbius. Okay, but it was not completely implementable, so it was modified and was used by the German army to send the message like a Morse code in the World War II. Okay, what does this Enigma engine will contain? What are the components of the Enigma engine are? One is the keyboard of 26 characters. If it is English, you'll be having 26 characters, entering a plain text of 26 characters maximum during encryption and cipher text during decryption. Keyboard will have 26 keys. Okay. Another component we have is the lamp board. Okay. Lamp board again have 26 lamps that shows the cipher text during encryption, which is the generated cipher text. If it is A, the lamp board will glow the light corresponding to A. 26 lamps from A to Z. If the cipher text generated, if it is A, the lamp with character A will be glown. If it is P, the lamp corresponding to P letter will be glowing, okay, which shows the character which gets encrypted or which is the cipher text generated during the encryption and plain text during the decryption. Okay. Apart from that, plug board with 26 plugs connected manually by 13 wires. Okay. 26 plugs will be there, okay, which are connected by 13 wires which are changed daily to generate random characters. Okay, it will be changed daily. The connection will be changed daily, and 3 wired rotors. There will be 3 wired rotors: fast rotor, middle rotor, and the slow rotor. Okay, how does they turn is the fast motor turns 1 out of 26 turns, chooses 1 character out of 26 turns. Okay, fast motor takes 26 turns to generate a new character for a plain text character. Suppose if you have a plain text character A, to randomly select a cipher text, it will rotate 1 by 26th. It will take 1 by 26th turn. Okay, it may be anywhere. Maybe 13th turn, 14th turn, 15th turn, or 20th turn. There will be 26 turns in which one turn will be chosen for ciphertext generation. Okay, fast rotor will be executed first. The middle rotor will turn again 1/26th time when fast motor completes its turn. When fast motor completes its 26th turn, the middle rotor starts its turning, okay, to generate the next ciphertext. And the slow motor will again generate the 1/26th turn when middle rotor completes its rotation, okay. It will be implemented one by one, not at a time. Fast rotor, middle rotor and the slow rotor will be implemented. And we'll be having a reflector which are stationary and wired to show the plain text and the ciphertext. Alright, here we have the diagrammatic representation of the actual Enigma machine that was used during World War II. Okay, they'll be maintaining a code book because anybody may be generating a message. So you need to have a record of how you are going to generate a ciphertext and a plain text. So they'll be maintaining a code book. Okay, this code book will be set for each day. It will be changed each day. What does this code book will have is 3 rotors to be chosen out of 5 available. There will be 5 rotors available. In that, best 3 will be chosen. So here we have the diagrammatic representation of the machine. We will be having 3 motors. Okay, one will be chosen for fast rotation, another for middle rotation, that is speed will be less than the fast rotor, and third will be slow rotor, which is still slower rotation than other 2. So we have fast rotor, middle rotor and the slow rotor. Alright, 3 rotors will be chosen. The order in which rotors are installed, which is the fast rotor, middle rotor and slow rotor. Next day, this may become the slow rotor. It will be changed to the 3rd position. This may become fast rotor. Now this will be changed to this. So rotation in this position will be faster. Rotation in this will be little bit slower than this. This will have again another slow rotation than the middle and the fast rotor. So setting for the plug board, each wire connection will be changed each day. How it will be changed depends on the person who is going to handle this machine. Okay, and a 3-letter code for the day. 3-letter, 1, 3 for 3 rotors. 3 letters will be chosen for 3 rotors. Alright, how does the encryption will be done in this is, set the starting position of the rotor to the code of the day, which is the code that we are going to use. The starting position of the rotor will be set for that particular character. Okay, for example, if code is HUA, today's code is HUA, the rotors will be initialized. Fast rotor is initialized to H, middle rotor is initialized to U, and slow rotor is initialized to A. Alright, now choose a 3-letter code, whatever may be the code, such as ACF. This is a code, plain text code. Encrypt the text ACF. This is the code to be encrypted. Okay, using the initial setting of rotors, that is HUA. What you will get is OPNABT. So this is random. Next time it may generate another character for this plain text. Okay, ACF is a plain text. For this, when you run this code HUA, it may generate OPNABT. Okay. set the starting position of the rotors to OPN when it is generated. For the next rotation, it is set to OPN, first 3 characters, half of the code. Okay, we'll be having half of the code. 3 rotors will be set to OPN. Okay, next, append the encrypted 6th letter OPN ABT to the beginning of the message, which specifies the key that has been used. Okay, OPN ABT will be uploaded or suffixed with the beginning of the message to know about the secret key that is used. Encrypt the message using 6-letter code and send it. Whatever message you need to send, encrypt that using this code and send through the cable so that it reaches the destination. Okay, this system will be updated or changed each day. Okay, this is an example for rotor cipher. All right, this is all about one of the symmetric key cipher, that is the substitution cipher. All right, this is how we'll be substituting one letter or one character in a plain text with another character in the cipher text. Now, we shall move on to the next concept, that is about the transposition cipher. All right, transposition cipher, this is another method. Substitution cipher, transposition cipher. Okay, what is the method of transposition cipher? How does the plain text are changed to cipher text in this transposition cipher? In substitution cipher, it will substitute the normal character in the plain text. But what about the transposition cipher? Transposition cipher does not substitute the character. It will not substitute anything, but it changes only the orders of the characters so that meaning of the message will be altered or it will become abnormal. Message will become abnormal or loses its meaning because character's position will be changed in the plain text, which generates or which is considered as the cipher text. Here in substitution cipher, a character A, if you have A, B, C, D as the message, you will be replacing all the 4 characters by like P, Q, R, S. You can change the character to this. You are substituting, you are changing. But in transposition cipher, what you can do is, this is substitution cipher. In transposition cipher, what I'll do is, I'll change the position of the characters. I'll change the position to like this or maybe like this. Maybe like this, or you can have permutation and combinations of the character position in the plain text. Now, this will become the cipher text. This will become the cipher text. All right. Example, first symbol appearing in the 10th position. Okay. Randomly, it will be changed. There are so many methods in changing the characters, position of the characters, which will be the topic that we are going to discuss now. Alright. In this transposition cipher, we have mainly 2 kinds. One is the keyless transposition cipher. Another one is keyed transposition cipher. So this is a transposition cipher where you don't have the key itself. You don't have the key in the keyless transposition cipher. Okay. There are 2 methods of permutation of characters. Here you would be performing the permutation operation on the changing the position of the characters in the plain text. Okay. What is the first method is, write column by column and transmit row by row. It will change. Suppose if we have a matrix of like this 1, 2, 3, 4, 5, 6, 7, 8, 9. When you transport it over the network, you will change the column to row and row to column. This will become 1, 4, 7, 2, 5, 8, 3, 6, 9. Write column by column and transmit row by row. If this is written like this, it will be changed to column to row. Okay, 1, 4, 7. When it is column on network path, while encrypting it, it will become 1, 4, 7. Okay, this is one method. Another is write row by row and transmit column by column. Here you can make it as same thing 1, 2, 3, 4, 5, 6. Row will be converted to column. Okay, 4, 5, 6 will become another column. 7, 8, 9 row will become another column. There are two methods. Write in row form and transmit in column form, or write it in column form and transmit it in a row form. Alright, here we have an example of the message. Okay, here the plain text is meet me at the park. The message is meet me at the park. Okay, is arranged in two rows. Okay, MEET, each character will become row. Okay, the position, the characters in the odd position will become one row. The character in even position will become another row. MEET, MEA, meet me at the park. Okay, so this will become set of rows. The ciphertext will be sent row by row. Okay, the ciphertext would be MEMATEAK. So this will be MEMATEAK ETETHPR. The encryption will be like this. Okay, it is arranged column by column and is sent as row. It is written as column wise, is it not? MEET MEATTHEPAK. You can write like this in a column wise. MEET MEETTHEPARK. You can have any random row. Now it will be sent as row, written as column, but as sent as row. MEMATEAK ETETHPR. Okay, so this is an example of writing by column and transmit row by row. Okay, Bob receives it. When he receives this cipher text, divides it into two equal parts. So this will be divided into two equal parts. MEMATEAK. How many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 characters is there. The Bob, the receiver, will split this into two sets. Okay, 3 plus 7, 8, one set of 8 characters and another set of 7 characters, two equal parts. First half is set as row 1. It will be set as the row 1, and second half as row 2, like this. Then he reads it in zigzag pattern. So it has been sent as a row. He'll read it as column wise, downwards, not horizontal. the receiver will read it column wise. The encryption was made horizontal, but decryption will be done as the vertical. Okay, like MEET, meet me at the park. Okay, this is known as the rail fence cipher. It will be read as a rail fence. Rail fence will be like this, column wise. The ciphering or the decryption will be done column wise or vertically. So it is called as the rail fence cipher. You know about how does the rail fence will look like this, isn't it? Column by column. It will be like this. In the same way, the decryption will be done column wise or vertically. So it is called as the rail fence cipher. So this is a simple transposition cipher, changing the position of the character. Okay. Another method is arrange plain text row by row and send it column wise. Number of columns should be agreed upon by Bob and Alice. How do you set the number of rows and number of columns? Must be previously agreed by both the sender and the receiver. You cannot say that there is a particular method to decide what is the number of rows and columns in the plain text. So both the sender and the receiver must agree upon the number of rows and columns in the text. Okay. Here we have another example of row wise example. Meet me at the park. You can set the matrix like this, row wise. So this is send row by row, meet me at the park, or it is sent as column wise. The previous one was row wise. This one is through column wise. It is made as a matrix, meet me at the park. It is sent as column wise, while decrypting it will be read as row wise. Meet me at the park, read as row wise, column and row. If send as row, read as column. If send as column, it will be read as a row. If you take another example of good morning, you can set in a row wise like this, G O O D M O R N I N G. So this will be coded as G O M R I G O D O N N. So it will be encrypted like this. Good morning will be encrypted like this. Now for decryption, you have to divide it into two parts. Here we have 6 plus 5, 11 characters. It will be divided into two parts. It will be arranged like this, G O M R I G O D O M N N. So it will be read like this, G O O D M O R N I N G. Column wise it will be read. Okay. If you take column wise, it will be like this. So this is arranged like this. When encrypting, this will become G M I O O N O R G D N. Like this, column wise it will be read. Now while decrypting, it will be made row wise. It will be arranged like this: G M I O O N O R G D N. So it will be arranged like this and is read column wise. Good morning. Okay, you don't have a particular key for this. You can make it row wise and column wise. In the matrix form, you can represent the message and you can decrypt it. Okay, so this is the keyless transposition cipher. Another method is changing the position. Okay, meet me at the park. We will take the integer values for this 1 to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now it will be changed randomly. Okay, second character in the plain text is moved to the 5th position. Okay, this 2 will be moved to the 2nd position. Okay, pattern will be 1, 5, 9, 13, 2, 6, 10, 13, 3, 7, 11, 15, 4, 8, 12. So it will be arranged in a matrix form. Second character in the plain text is moved to the 5th position. Second character is moved to the 5th position. Now the encryption pattern will be like 1, 5, 9, 13 is a set. 2, 6, 10, 13 is another set. 3, 7, 11, 15, 4, 8, 12. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So pattern will be changed like this: 1, 5, 9, 13, M, M, T, A will be encrypted like this: 2, 6, 10, 13, E, E, H, R. Here we have the set of 2, 6, 10, 14. Then we have 3, 7, 11, 15. It will be E, A, E, K. Then we have the 4, 8, 12 set, that is T, T, P. We can encrypt like this. So it will be encrypted M, M, T, A, E, E, H, R, E, A, E, K, T, T, P. So it will be encrypted like this. Reverse task will be done for decryption. We don't use any key here. That means it will be very much difficult for the adversary to guess the arrangement of the characters, changing of the position of the characters. If you look at the cryptanalysis of the keyless transposition cipher, the exhaustive key search attack and the statistical attack will be very much difficult in case of transposition cipher, because for both the methods, even you can make the attack of statistical attack or frequency attack, because if the number of characters are repeated, you can make a statistical attack, but it is difficult to find out the actual message because you don't have any key. For both exhaustive search and statistical attack, you need to have a key. When you don't have a key, it will be very much difficult for the adversary to guess the key or estimate the key in a cryptographic method. Okay, this is an example of keyless transposition cipher. Okay, now we have keyed transposition cipher. In this keyed transposition cipher, the algorithm is going to divide the plain text into groups of predetermined size. It will be again a type of block cipher. Here it will be divided into blocks of text, of plain text, and use a key to permute the characters. Permutation will be done for the characters in the plain text in each block. First thing is dividing the plain text into number of blocks and using the permutation operation to change the position of the characters in each block, not in entire character. Transposition algorithm is applied for each of the block in the plain text. For example, if you consider a plain text, enemy attacks tonight. This is the plain text. Okay. How do you encrypt this message is the sender and receiver agrees upon a set of blocks. How many blocks the data can have? For example, say we have 5 blocks, okay, in this text. Okay, we have 19 characters in this message. Okay, 19 characters will be divided into blocks of 5. We need to have 5 characters in each block. That means you can have 4 blocks of text. Since it has 19 characters, a dummy character Z is appended at the end of the message. Okay, this will be divided into blocks enemy, ATTAC, KSTON will be another block, IGHT will be 4 characters. Therefore, a Z is appended to the last block. Okay. Now, we have 4 blocks of 5 characters. Okay. A permutation key is used because it is a keyed transposition cipher. We make use of a key for permutation operation, which will be used by both the sender and the receiver. Sender will use it for encryption and the receiver will use it for decryption. All right. And it will be shown as this. It will be 31452 12345. So this is a permutation which performs the encryption as well as the decryption. All right. Here we have the example enemy attack KSTON IGHTZ 4 blocks. Encryption will be done with each block 31452. This will be encrypted like this. Third character will come to first position. Then first character will come to second position. E. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This key is applied for all the 4 blocks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. It will be 31452. 3, 1, EE, 4, M, 5Y, 2, N. It will be encrypted like this and decryption will be 1, 2, 3, 4, 5 again. Okay. Next we have 3. It is T, A, again 4, A, C, 5, C, 2, T. Okay, TEA, CT. Next we have KSTON. Third will be T. First will be K. Now we have 3, 1, 4, 5, 2. 3, 1, 4, 5, 2. Now we have again H, 3, I, 1, T, 4, Z, 5, G, 2. 3, 1, 4, 5, 2. When you decrypt this, again 3, 1, 4, 5, 2. 3, 1, 4, 5, 2. When you decrypt this, it will become again E, N, E, M, Y. So it will be encrypted. 1, 2, 3, 4, 5. Back to the position, back to the plain text form. So the encrypted character will be like this: EEMYN TAAC TTKONS HITZG. Okay, you will be using this key to change the position of the characters. Okay, so Bob performs the reverse operation to get the plain text. Okay, so this is about the keyed transposition ciphers. How you can use a simple key to change the position of the characters. In the next session, I am going to explain about combining these two approaches, that is keyless as well as keyed transposition cipher. Thank you.